Sometimes I even have 2 pens in my ears. At some point during the day, it's like devil horns. Yeah.
Rock on.
Yeah.
Well, you're all fancy today for your presentation.
For my presentation.
Here we are at Chapter 12, Test Hints.
Yes, the end of the year is in sight.
Woo!
Yes.
And we want to make sure you have a chance to go over these before you see some of these things on your final.
Yeah. This particular topic, this stoichiometry stuff, just like we told you at the very beginning of the chapter, it brings everything together.
Yeah.
If you were having problems in chapter 9, if you were having problems in chapter 10, if you were having problems in chapter 11, then you need to get back on your little Moodle horse and giddy up back through those other chapters, because
check the book, check your notes, check Monster, practice writing formulas.
Check our office hours and come in and get some actual FaceTime.
Help after school and stuff.
Imagine that.
Okay, so this test is short and sweet, only 20 questions, and a lot of it is doing some sample problems, so we'll kind of talk you through how to solve those. And we start with a very easy one. The test hint says define stoichiometry. Excuse me. Stoichiometry, that's our recipe for a chemical reaction, and
we should just tell them to look that up.
Well, we do, but you know,
it's getting soft as the end of the year is coming around.
Big word. We want it to do well.
Okay.
So it's the relationship of the quantities, the actual putting the masses in with the stuff in the balanced reaction, and see, you know, what if we put in this much, how much product will we get out? That's what stoichiometry is all about.
The algebra of chemical reactions.
Okay. Number 2.
Number 2, use ratios to answer a question about making brownies. Well, depending on when you're watching this, you've already done the brownie lab. And so you're given a recipe, and a recipe tells you about ratios.
Right. So you could almost take the ingredient list off the box of a box of brownies.
Yeah, a third of a cup of this, 1 cup of that.
This and this and this and this and this yields brownies.
Right.
And this question will have like amounts in it, like a cup of sugar, or a third a cup of shortening, or an egg and a half, and that kind of stuff. So look at, use it like proportions.
Use those ratios. And yeah, set them up like proportions and cross multiply and divide, and
that's all it is.
You can do it that way.
Okay. Test hint number 3. Describe the law of conservation of mass as it applies to the total mass of the reactants compared to the total mass of the products. Well, I'm really not sure what wasn't mentioned in this test hint, because the total mass of the reactants has to equal the total mass of the products.
Every time. Well, but what if you're not given any masses? What if you're just given, like, a balanced chemical equation?
Well, then you could use molar masses and atomic masses from the periodic table.
Yes.
Kind of the idea that if you put in 5 grams of this and 2 grams of that to make a product, you're going to get
7 grams of product.
Right.
Yeah. Okay, cool.
Make that a dance the way we're going.
Yeah, you probably could.
Number
4. Identify the first step in most stoichiometry problems. The first thing you have got to do is you have got to have a correctly written and balanced chemical equation.
Okay. And you get that, and you have your balanced equation, you're ready to jump into the math. Then what?
Then you need to look at what's given,
use
that given, and 9 times out of 10, you're going to have to take a given mass and convert that to moles.
Moles. We've been all about the mole.
So you're given the mass of some substance, and you have to convert that to moles.
Alrighty, moving on. Identify a mole ratio in a given balanced equation. So we have this balanced equation here on the board, and we're going to refer to that one many a time just as these sample problems. And if Mr. Sesson could so they can see it.
Yep.
2 moles of KClO3 and forms 2 moles of KCl and 3 moles of O2. Those coefficients tell you the mole ratio, and this is a question just about the mole ratio. So if we say, what is the ratio of oxygen to potassium chlorate? All you gotta do is look at the coefficient in front of oxygen and the coefficient in front of potassium chlorate, and that's simply a 3:2 ratio. Just a basic comparison. Don't try to make that kind of a problem harder than it is.
My students have been curious, does it matter if we put 3 to 2 or 2 to 3?
Well, it depends on what they're asking.
If you label
Right.
the 3
Oh,
and
well,
label the 2,
yeah.
isn't it easier to decipher?
Yeah, yeah. I mean, if it's labeled and clearly identified so
Right.
that the reader understands what the writer is trying to say. Yeah, that could work.
Okay. Number 6, going back to a chemical equation, a correctly written balanced chemical equation, you have to interpret a chemical equation in terms of particles.
Right. So, like,
Molecules, atoms.
what does this equation mean?
Yes.
Molecules and atoms?
Yes. If you read it, like a dedicated motivated student ought to, you're going to read 2, technically they're formula units, of potassium chlorate decomposed to form 2 formula units of potassium chloride and 3 molecules of oxygen.
But that also means moles. So it stands for 2 moles of potassium chlorate, forming 2 moles of potassium chloride, 3 moles of oxygen. And if we think about it, we can do something else.
Why don't the numbers change?
Well, because the moles are always the same amount.
It's all multiples.
Right.
It's
Multiples.
just,
It's multiples.
it's a multiple of Avogadro's numbers, so they're still in the same ratio.
Right. And we could even use this to figure out what the mass would be. We would take 3 times the molar mass of oxygen and pull the gram amounts out of that. We had a great video posted for you on Moodle that, with a question that asked you all about this and the different things that this stands for. And you know what? I think we have it in our notes too, that is accessible to every student. Like the first section tells, this is what an equation is.
But they would have to go to Moodle.
Yeah, or their websites, and they would have to open the notes that are freely abounding in the building, and it's okay, they'll do that.
That sounds too hard.
No,